At 8 o'clock on the morning of the 24th of December, 2022, about 46,000 megawatts of generating capacity in the largest grid in the eastern United States was not running. That is over 24% of its fleet, out in a single hour, and 70% of what was missing burned natural gas. The inquiry into that storm records something stranger than the number. In one sentence, multiple natural gas-fired generating units reported their inability to perform during that period. In many cases, only when called to find out why they had not come online. The grid operator learned that a power station could not run by telephoning the power station to ask why it had not started. Not from a gauge, not from a pressure reading, not from an alarm, from a phone call at the worst hour of the worst day. Every other kind of power station keeps its fuel where somebody can see it. A coal plant has a pile in the yard. A hydroelectric plant has a reservoir behind it. A nuclear plant has a core loaded 18 months ago. A gas plant has a pipe. The pipe belongs to somebody else. So does the compressor that pushes gas along it and the well that produced it. The fuel is not on site. It is in transit across a chain of companies, and nobody running the grid has a meter on any of it. There is a number federal investigators went looking for in 2 different storms and could not produce either time. They say so in print in one line. Nobody in the control room could see the fuel. The chain that feeds a gas-fired power station has 6 links, and the standard governing winter readiness in North America touches exactly one of them. It starts at a wellhead, where gas comes out of the ground wet at pressure, mixed with water that will freeze. It runs through gathering lines, the low-pressure pipes that collect several wells into one stream. Then a processing plant, which strips out the heavier hydrocarbons and the liquids. Then compressor stations, which put the pressure back in and push the gas along. Those compressors run on electricity or on gas, and either way they are machines that can stop. Then the interstate pipeline, which may run 1,000 miles and serves everybody along it. Then a fence, and behind the fence, the generating unit. The mandatory rulebook begins at that fence. The cold weather standard applies to generator owners and generator operators. The only fuel-side objects inside it are what the standard calls fixed fuel supply components, and it defines them precisely. Non-mobile equipment that supports the reliable delivery of fuel to the generating unit, and under the control of the generator owner at a plant site. Under the control of the generator owner at a plant site, those 2 clauses are the whole boundary. Wells, gathering lines, processing plants, compressor stations, interstate pipelines. All of it sits outside every applicability clause in the standard, not by oversight. The definition was written that way and is doing exactly what it says. A grid operator can compel a power station to prepare for cold weather. It cannot compel the thing that feeds it. Everything before the fence belongs to somebody else. Appendix C of the Elliott Inquiry, printed page 158, is 2 pie charts and a box, and it is where every argument about that storm starts. By total megawatts lost across the event, gas, 230,959 megawatts, 63% from 822 units. Coal and lignite, 84,668, 23%. Oil, hydro, and biomass together, 29,000, 8%. Wind, 14,528 megawatts, 4% from 340 units. Solar, 3,575. Nuclear, 1,527, 1% each. The box gives the totals: 1,702 units, 3,565 outages, 364,256 megawatts. So gas was 63% of the megawatts out and wind was 4. Both sides of the public argument then do the same thing with that. They divide each fuel's outage by that fuel's share of the fleet to get a failure rate. That division cannot be performed on this document, and the reason is a mismatch of populations. The outage figures are drawn from what the report calls the event area. The capacity mix, in Figure 11, is drawn from something narrower, called the core entity footprints. Different areas, different denominators. The report never performs the division anywhere in 167 pages. What it says instead is one clause. Gas dominated because of the large percentage of natural gas-fired generation in the event area, nearly 42%. There is one failure rate in the whole document, and it is not per fuel. It is one operator's own fleet-wide figure. 24% forced out, against 22% in the polar vortex of 2014. The fraction cannot be written. In 2024, for the first time, a North American reliability standard required a generating unit to have a minimum temperature at all. The federal regulator's own words on why. The previous standards contain no minimum temperature operating requirements. The new one is called the extreme cold weather temperature, and the standard defines how to compute it. The lowest 0.2 percentile of the hourly temperatures measured in December, January and February, from the 1st of January, 2000, through the date the temperature is calculated. It is calculated by the owner of the unit, filed by the owner of the unit, and it becomes the temperature that unit is expected to survive. Go back to December 2022, when no such requirement existed but units had documented operating temperatures anyway. The inquiry did something with those. It did not compare fuels. It compared every unit to the floor its own owner had written down. Over 75% of the generating unit failures caused by freezing happened at temperatures above the unit's documented operating temperatures. Above, 3/4 of the freezing failures happened while it was still warmer than the machine's own paperwork said it could take. For mechanical and electrical failures, the figure is 87%, and nearly 39,000 megawatts was lost on units whose design temperature was 10 degrees Fahrenheit or more below the temperature at which they actually failed. 10 degrees of margin on paper unused. This is the comparison that belongs to nobody. It needs no fleet share and no opinion about which fuel anybody prefers. The expectation was written on the machine by the machine's owner in a filing. None of them reached the floor they wrote. On printed page 98 of the Elliott Inquiry, there is a breakdown of what actually froze, and the largest single category is not what anyone pictures. 42% of all the megawatts lost to freezing were lost to frozen transmitters, sensing lines and instrumentation. Not turbines, not blades, transmitters. The small tubes that carry a sample of fluid from the machine to a gauge so the machine knows what it is doing. They are narrow, often outdoors, and in many designs they contain water. Water in a 1/4-inch tube freezes long before anything structural does. And when the instrument freezes, the control system stops trusting it and the unit trips or refuses to start. The machine is intact. Its senses are not. Now the reclassification, which the report performs on itself. Freezing was 31% of the megawatts lost. Mechanical and electrical issues were 41% and were reported as a separate category. But over 80% of the incremental unplanned megawatts lost to mechanical and electrical issues occurred when generating units began to experience below freezing temperatures. And 87% of those losses happened above the unit's own documented operating temperature, the same signature as the freezing failures. So the report draws the conclusion itself, in careful language, about its own headline number. Some portion of the mechanical and electrical issues outages may have been more appropriately categorized as freezing issues, which means 31% is a floor, not a measurement. The document is telling the reader that its own largest category is partly misfiled, and it does not say by how much. The freezing number is too low. Lower 48 dry gas production fell to its lowest point of the storm on the 24th of December, 2022, and the inquiry gives that figure twice, 82.5 billion cubic feet a day, a decline of 16%, citing the Federal Energy Information Agency, and 82.9 billion cubic feet a day, a decline of 18%, citing a commercial data provider. Those are the same quantity on the same day in one report, and it does not reconcile them. Notice that the lower production figure carries the smaller decline, which means the two sources are counting down from different starting points. This film gives both, because the document gives both. The largest single-day drop was 8,368 million cubic feet a day, between the 22nd and the 23rd of December. And this was not a Texas event. The Marcellus Formation fell 23%, the Utica fell 54%. One warning about that pair. The executive summary compresses them into the phrase 23 to 54%, and that is a range across two formations. It is not an uncertainty band. All but one of the producers who answered named freeze-offs at the wellhead as the primary cause. 7 of 10 also named failures downstream of them, in gathering, compression, and processing. And inside production there is already a small loop, which the report states in one clause. A pipeline that could not accept gas forced producers to idle equipment, which itself exacerbated production equipment freezing and caused further reductions. Shut a well in to protect it, and the shutting in is what lets it freeze. The remedy and the fault are the same action. The shutdown made the freezing worse. At 26 minutes past 1 in the afternoon on the 24th of December, 2022, Consolidated Edison declared a gas system emergency in New York City. Its 4 interstate pipelines were reporting storage withdrawals at maximum. Line pack, the gas held under pressure inside the pipes themselves, was expended system-wide. The inquiry states what was at stake in one sentence. Had Con Edison's city gate pressures continued to decline, it was in danger of losing pressure below the level needed to operate the system, resulting in loss of service to all or portions of its system. That is domestic heat in a city in December. It did not happen. It came close enough that the operator declared an emergency. The mechanism generalizes. A later reliability assessment puts it plainly. Generators that lack firm supply and transport arrangements are at risk of fuel unavailability. When winter weather also impacts gas production facilities, the resulting imbalance in pipeline injections and withdrawals can imperil even firm pipeline customers' supply, as preparatory line pack is rapidly depleted. Line pack is a buffer, and a buffer with 2 customers drawing on it is not 2 buffers. When it is cold, houses want gas for heat and power stations want gas for electricity, and both draw from the same volume, at the same hour, through the same pipe. The power station has no reservoir, neither does the city. What they have between them is the pressure in a pipe, and pressure is not storage. The Elliott inquiry keeps a tally of how often this has come close, and prints it in the executive summary, twice in 11 years. On printed page 142 of the Elliott inquiry, there is a survey result that describes a circuit nobody closed on purpose. When a grid runs short of generation, operators shed firm load. That means cutting power to circuits in blocks to keep the rest of the system standing. Some of those circuits feed gas infrastructure, compressors that run on electric motors, processing plants, and heat trace, the electric heating tape wrapped around small pipes to stop exactly the freezing described earlier. So cutting power to keep the grid up can cut gas to the plants that keep the grid up, which forces more load shed. That is the loop. The defense against it is administrative, not physical. A facility can ask its electricity provider to designate it a critical or protected load, and it is then excluded from the blocks. Here is what the inquiry found. All 10 of the natural gas producers who provided information in conjunction with the inquiry responded that they do not identify any of their facilities as protected or as critical loads, even though winterization systems, including heat trace, can be dependent upon utility-provided electric power. All 10, none, including the ones whose freeze protection runs on the electricity in question. Of the processing plants, 25% had critical load protection. Of 15 interstate pipelines, 4 had designated any facility at all. And of the 60 facilities those 4 designated between them, 42 belong to a single pipeline. So one company did most of the protecting that exists, and the rest of the chain sits on ordinary circuits, in ordinary blocks, waiting to be shed. The loop is not a theory. It is drawn, it is live, and the switch is open. Almost every marker on it is hollow. In February 2021, the same investigators looked at the same loop in Texas and the south-central United States and found it closed. Their words on the survey: most of the natural gas production and processing facilities the team surveyed were not identified as critical load or otherwise protected from manual load shedding. The same finding in a different year in a different grid. Then a sentence about who expected what to happen. Because it is not the entity that implements load shedding, the grid operator did not anticipate that firm load shed would contribute to power outages of natural gas production and processing facilities. That would in turn contribute to the decline in natural gas supply and delivery to natural gas-fired generating units. Nobody was watching the loop, because the party that would have watched it does not operate the switch. Then the finding itself, and it is the only place in either inquiry where the circuit is recorded as having run. From early February the 15th through February the 18th, the implementation of manual firm load shed by 3 grid operators to preserve reliability partially contributed to the decline in the production of natural gas. Partially contributed, that is the loop turning. The report bounds how hard. Across the whole event, loss of power supply to gas infrastructure caused 23.5% of the decline in gas production. On the 17th of February, the day of maximum production loss of power caused 21% of the decline, against 44.5% caused by freezing and weather. Against that, December 2022, where power lost to Appalachian processing maxed out at 5.6% of lost volume. In February, the loop turned. February the 14th, 2021, is the line the February inquiry draws through its own data, and it takes one sentence. It sorts the gas-fired units with fuel supply problems by whether those problems began before or after the first firm load was shed. 60% of all natural gas-fired units affected by natural gas fuel supply issues had already experienced outages, derrits, or failures to start by February the 14th, before any firm load had been shed. 32% had fuel supply issues both before and after. 3/5 of the fuel starvation was already in place before the first customer lost power. The loop is real, and the loop is not the origin. Both are in one document, 4 pages apart. Weather and freeze-related causes were 58% of the decline in gas production. Fuel issues were 31.4% of all unplanned outages, derrits and failures to start, the second largest cause of anything, and 87% of them were natural gas. 357 gas-fired units across the 3 grids, with 1,121 separate outages, derrits or failures to start between them. And of those units, only 29% held both a firm gas supply contract and firm pipeline transportation. 109 out of 357 had bought the thing that was supposed to guarantee delivery. Then the sentence this film has been walking toward. Because many critical natural gas infrastructure loads had not been identified during the event, and both power outages caused by weather and firm load shed were coincident during this time frame, the extent of power outages to critical natural gas infrastructure loads due to firm load shed is unknown. The extent of it is unknown. 2 pages of one reliability assessment, published for the winter of 2025 and 26, hold both halves of this, and they do not appear to be in conversation. Page 7, about generators. Cold weather reliability standards first introduced in 2023 have been improved prior to the upcoming winter, with 99% of total net winter capacity reporting the ability to operate at the calculated extreme cold weather temperature. Page 9, about the fuel those generators burn. Natural gas infrastructure freeze protection mitigations are voluntary for the natural gas industry in most of North America, resulting in uneven application of protections and continued supply risks during extreme conditions. Generators are now mandatorily regulated. Their fuel is not. The Elliott Inquiry staff say why. No regulatory entity is tasked with ensuring the reliability of the natural gas fuel supply relied upon by the grid. The team recommends that Congress exercise its regulatory power over natural gas infrastructure necessary to ensure grid reliability, as it did with bulk power system reliability in 2005. There was once no mandatory rulebook for the grid either. It was made by statute after a cascade. It is not only a rulemaking gap, it is a measurement gap, and the inquiry hit it while rioting. Only 38 to 53% of production entities supplied data for the worst 4 days of the storm. One producer never responded at all. The footnote explains, because these entities are not subject to the Commission's jurisdiction, the team did not receive all data requested. There is one named exception. Texas legislated after February 2021. Gas facilities on a new supply chain map, directly serving gas-fired generating units, must prepare for weather emergencies and are subject to inspection. Read the qualifiers on a map directly serving designated critical. The fence moved and did not disappear. The first enforceable cold weather standard for generators in North America took effect on the 1st of October, 2024. The current version took effect a year later. There is a widely repeated claim about the next date in that sequence, and it is wrong. The claim is that everything must be winterized by the 1st of October, 2027. That date is in the standard, but it is not a deadline. It is the line between a new unit and an existing one. The deadlines that matter are inside Requirement 7, and they are long. For any action requiring new freeze protection, the timetable must specify completion within 48 calendar months of completing development of the corrective action plan. For remedying issues with existing freeze protection, 24 months. And if the owner cannot meet either, it may request an extension. Take a unit that needs new freeze protection when the existing unit requirement bites, the 1st of October, 2025. Add 48 months. That work is legally complete on the 1st of October, 2029. Later, with an extension. The storm that started this was the 8th to the 20th of February, 2021. One more clause, because it applies right now. Until the 1st of October, 2027, the Compliance Authority will not pursue an action against any entity acting in good faith regarding the extreme cold weather temperature. That temperature is the number each owner calculates for itself, and it is the input to 4 other requirements in the same standard. So for 2 more years, a wrong number at the top of the chain carries no penalty, and everything computed from it inherits the protection. Count the interval from the storm to the backstop. 8 years and 7 months. On the 1st of October, 2025, the continent's reliability organization filed its first full compliance dataset for the cold weather standard, covering the winter before. 1,224 generator owners out of 1,258, 6,806 units, 1,079,237 megawatts, 99% of capacity, able to operate at its own extreme cold weather temperature. Underneath that, four things. 274 units, 41,694 megawatts, hold a formal cold weather constraint. That is an approved excuse from freeze protection. 203 of those units are wind, and 180 are excused under a single rationale: technical, no commercially viable solutions. 45,449 megawatts, 4% of the fleet, declared an extreme cold weather temperature above freezing point, which limits their obligations to paperwork. The filing flags the oddity itself, noting units in northern Texas and southwest Utah reporting this, while geographic neighbors reported below freezing. 46,013 megawatts, another 4%, declared a temperature lower than the unit's own minimum operating temperature. And peak forced outages still reached 68,519 megawatts on the 20th of January, 2025, which the filing calls within the normal range. The 99 did not move. In December 2023, the federal regulator approved a settlement covering the penalties charged to generators that failed to perform during the storm of the previous December. The Market Monitor's report states both numbers in one sentence: $1.796 billion, reduced to $1.226 billion in a settlement. Almost every account stops at the first figure. The reduction is 31.7%, and it is rarely reported at all. The scope was roughly 200 market participants and 277 performance assessment intervals, about 23 hours of charge time. The grid operator later narrowed the definition that triggers those intervals. Its own contention, recorded in a later order. Had that definition been in place during the storm, the total would have fallen from 277 intervals to 73. About 6 hours instead of 23. 15 generators filed complaints, and the agreement that ended them had 81 settling parties. The only objectors were two companies owed money out of it, and the regulator denied their intervention, so it is recorded as uncontested. One case reached a court, and the petition was denied in July 2025. The plant was W.H. Sammy's, which opens the cascade in the first film on this channel. The court's opinion puts the penalty at $12 million. The settlement agreement puts it at $11,019,473.20. Both documents are primary. This film does not choose. The reliability inquiry runs to 167 pages on why the machines failed, and does not contain one word about any of the money. 2 investigations, 2 storms, 1 loop, and 1 quantity neither could produce. Nobody had labeled the facilities.